Good evening all. Welcome to the week 12 tutorial class of basic electric circuits. Let us start with the first problem. Two elements P and Q are connected in series as shown. If the current in the circuit is given, then the values of P and Q are. So you are given a voltage source and you are given two elements and you already know what is the current through the circuit. You have to find what P and Q are, whether it is a resistor, inductor or capacitor, and then what are the values if it is a resistor, inductor or a capacitor. So I'll give you 5 minutes to solve this question. Please solve it. So if I draw a phasor diagram, so phasor diagrams are drawn for a particular frequency. Since both your voltage and current are of the same frequency 4, so you have your omega is equal to 4 radian per second and you draw the phasor diagram for 4 radian per second, and since both are expressed as cosine functions, let us take cos as the reference phasor. That means any phasor which lies on this axis will be the magnitude of that phasor angle 0 degree. So let us draw both these phasors in this reference frame. So keeping cos as reference, your voltage phasor is 12 cos 40 plus 30. It is 30 degree leading the reference because it is plus 30. So plus 30 means you have to move in the anti-clockwise direction 30 degree. That is plus 30 means anti-clockwise direction 30 degree should be moved. So this is your voltage vector. Now its magnitude is 12. You can take the peak value as magnitude. Generally we use RMS as the magnitude. So 12 angle plus 30 degree is your voltage vector. Now you have your current. Now current is magnitude is 0.5 and angle is minus 30 degree. That means you have to move minus 30 degree means you have to move clockwise direction. You have to move clockwise direction 30 degree. That means you have to move in the clockwise direction 30 degree will be your current vector. So this is 30 degree. So you see between your voltage and current, the angle is 60 degree. This much information are not required in this problem, just showing you how to express these vectors in terms of in the vector domain or in the phasor domain, how to represent them. So my reference is cosine. So my voltage phasor given in the problem is 12 is the magnitude and it is 30 degree in the clockwise direction, anti-clockwise direction. So it is 12 angle 30 and your current is 0.5 angle minus 30 degree. So you have a circuit, the voltage across it is 12 angle 30 and the current through it is 0.5 angle minus 30. If this is the case, the impedance of the circuit is given by the voltage across the impedance by the current through the impedance. Impedance is a vector quantity. So you have 12 angle 30 divided by 0.5 angle minus 30. So this will come out to be 24 angle 30 plus 30. When it goes into the numerator, it becomes 30 plus 30. So this is 24 angle 60 degree ohms. That means you can break it down into 24 cos 60 plus 24 or J24 sine 60, that much ohms. Now you know that the real part of your impedance is the resistance and the imaginary part is the reactance. So you have your resistance value is 24 cos 60 and the reactance value is 24 sine 60. Now you know that resistance there are only one value, but for reactance could be an inductor or a capacitor. Now how do we decide whether it is an inductive reactance or capacitive reactance? So now if you see the inductor whose inductance is L, the impedance or the reactance is omega L and the impedance is Jx, which is J omega L. And in the case of a capacitor, for a capacitance C, the capacitive reactance is 1 by omega C or Z is 1 by J omega C. So the impedance offered by an inductor is J omega L and the impedance offered by a capacitance is 1 by J omega C. Now if you multiply both numerator and denominator with J, the numerator is J whereas the denominator is J square omega C. Now root of minus 1 is nothing but J. That means J square is minus 1. So this makes it minus J by omega C. That means the impedance of an inductor is j omega L and that of a capacitor is minus j by omega C, which means if the impedance is positive for an inductor and it is negative for a capacitor, because the general impedance is expressed as R plus J X, where your R is a resistor and X is the reactance. So the reactive impedance is positive for an inductor and negative for a capacitor. Now let us see our problem. So in this problem you got your Z as 24 angle 60 degree ohms. This means 24 cos 60 plus j 24 sin 60. Now 24 sin 60 is a positive value. That means your other element is nothing but an inductor. So inductor whose value is 24 cos 60. Now what is cos 60? Cos 60 is 1 by 2. So this is 12 ohms and your reactance is 24 sin 60. Now sin 60 is 0.866 times 24 is 20.78 or it is 12 root 3 ohms. So now you know that your reactance is nothing but omega L. Now what is omega? Omega is the frequency of your supply and it is given in the question as 4. So your omega is 4. That means 4L is 12 and root 3. That means L is 12 root 3 by 4, which is 3 root 3. Now 3 root 3 is 5.19. That much Henry. So the resistance is 12 ohms and the inductance is 5.19 Henry. This is the answer. Now let us take the case when the current is leading. So let it be the same circuit, which is 12 cos 4t plus 30 is your supply and you have P and you have Q. But now the current in your circuit is 0.5 cos 4t plus 60. If it is plus 30 then means both are in phase. So I am taking as plus 60. So in the phasor domain if you draw, you are taking cos as your reference. Your voltage is plus 30. That means it is in anti-clockwise direction 30 degree. So this is your voltage phasor. Now your current is plus 60 with the same frequency. Take a note, you will draw the phasors, when phasor diagram is drawn, you will draw all the phasors in the same frequency. Like that means phasor diagram is drawn for a particular frequency. So your current is somewhere here, which is 60 degree anti-clockwise direction. So I can represent the voltage as the magnitude 12 angle 30 degree volts and the current as 0.5 angle 60 degree ampere. So we'll follow the similar method. Now you have your impedance as the voltage by current. So the voltage is 12 angle 30 and your current is 0.5 angle 60. So this becomes 24 angle 30 degree minus 60 degree, that much ohms, which is nothing but 24 angle minus 30 degree ohms. So your Z is now 24 cos minus 30 plus J 24 sine minus 30, that much ohms. Now cos is an even function. Even function means cos theta. If you take theta as minus theta, it will be same as your cos theta, where that means cos is an even function. Because in the graph you see, this is your cosine wave. Now whatever goes to t, the same goes to minus t. That means cos theta is cos minus theta. Whereas if you see sine is an odd function. That means sine of minus theta is minus sine theta. So if you apply this in this impedance equation, so Z is 24 cos minus 30 plus J 24 sine minus 30. So cos minus 30 is nothing but cos 30. It's an even function. Whereas sine is an odd function. So sine minus 30 is minus sine 30. So this will bring us cos 30 is 0.866. So this is 12 root 3 minus J 24 sine 30 is 0.5, which is 12. So this is your impedance, where this is your resistance, and you see that your impedance is now negative, the reactance part. That means this whole guy is a capacitor. That means your resistance is 12 root 3. 12 root 3 is nothing but 20.78 ohms. And your reactance is capacitive, which is 1 by omega c. The magnitude is nothing but 12. Now omega, you know, it is as 4. So that means your c is 1 by 12 times omega, or 1 by 12 times 4, which is 1 by 48. Now what is 1 by 48? It is 0.02. So your capacitor is 0.0208 farad. So just see, now your current just leaded your voltage by 30 degree. If you substitute your Q and R, P. So earlier in the circuit, if it was R and L, then the phasor diagram was voltage was here and current leaded the voltage by 30 degree. Sorry, current was lagging the voltage by 30 degree. Now if you turned it to a capacitive circuit and you change the resistive value. So earlier it was 12 ohm. This was 5.19 Henry. So at 4 radian per second, your current lagged your voltage by 30 degree. Now at the same 4 radian per second, you replace the resistance with 20.78 and your capacity, you added a capacitor of 0.28 farad. Now in this case, your voltage is here, but your current is leading your voltage by 30 degree. Sorry, earlier it was 60 degree. So adding a capacitor will improve your current, becomes more close to the voltage. So for inductive circuit, the current lags voltage. For inductive circuit, the current lags voltage. And for a capacitive circuit, the current will lead the voltage. This is how you solve problems of this sort. So in this problem, you learned how to draw the phasor diagram, how to take the reference, how to find the impedance, and among impedance what are the two types of reactances and which are positive, which are negative. From seeing the current and voltage itself, you should say that whether it is an inductive or capacitive circuit. That is why the inference which we drew, that for an inductive circuit the current will lag voltage, for a capacitive circuit the current will lead the voltage. Now let us go to the next problem. Please solve this. For the circuit shown in figure, the Thevenin voltage and impedance Z Thevenin across the terminal AB is. So whenever we want to find the Thevenin equivalent circuit of any complex circuit, so if you have a complex circuit having lot of sources, passive elements like inductor, resistor and capacitor, you can simplify the circuit forming an equivalent voltage source in series with an impedance across the two terminals across whom you have to find the equivalent circuit. So this impedance is called the Thevenin impedance and this supply is called the Thevenin voltage. So it could be AC or DC. So in the given circuit it is an AC system. You are asked to find across AB what is the Thevenin voltage and what is the Thevenin impedance. So let us start with Thevenin impedance because the circuit has only independent sources. So if you have only independent sources, to find the Thevenin equivalent impedance, you just replace the sources with their equivalent internal impedance. That means for a voltage source, the equivalent internal impedance is connected in series with the voltage source. So this is the internal impedance of this voltage source. So this is a voltage source dash. Then the reality is the Vs dash is what we get outside. So this is your Vs dash where this is your real Vs. There will be a drop across the impedance. In Thevenin system, you just replace with their internal impedance for an ideal case. That means for an ideal voltage source. So this voltage source is an ideal voltage source. The ideal internal impedance. When does ideal happen? Ideal happens when whatever is produced by the source is reached at the terminals. This happens only when your Zs is 0. So the ideal internal impedance of a voltage source is 0. If you take a current source, the practical current source has an internal impedance which is connected in parallel to the source. So if Is is the real current, real value which is produced by the source, some part will go to the internal impedance and what we get outside is Is dash. So this is a practical case. But for ideal case, your Is dash is 0. And this occurs only when your Zs tends to infinity. That means if you want to find the Thevenin equivalent impedance, you replace all your voltage sources with short circuit and all your current sources with open circuit. That means Z is equal to 0 means it is a short circuit. There is no impedance along the path. And Zs tends to infinity means you replace it with a open circuit because there is no current flowing through it and the impedance tends to infinity. So following this, for the given problem, you have an inductor, you have a current source, you have a resistor, another inductor and a current source. So let me redraw this. So you have a current source, alternating current source. You have an inductor here, you have a resistor here, you have another inductor here. So is it in parallel or parallel? And you have another alternating current source here. So these are your terminals A, B. So first I'm trying to find the Thevenin equivalent impedance. So for finding ZTH, when the circuit has independent sources, you replace the current source with open circuit and voltage source with short circuit. So you have two current sources, you just open circuit them. So your circuit will look something like this. So these two are open. So you have J20, J40, 20. What is the impedance when you look across this? So when I take my A and B here, the A will go to the resistor, then to an inductor, and B will go to an inductor. They both meet at, let this point be C. This also C. So this is now a series RL circuit. So you have 20 ohms, you have J20, J40, I have J20. So Z Thevenin. So that Thevenin is what you get when you look across AB. It is nothing but 20 plus J40 plus J20 because they are a series, they are connected in series. So you can add all the impedances. So this is 20 plus J, 60 ohms. So you got first part of your question, which is a Z Thevenin. Now let us find out what is the Thevenin equivalent voltage. Thevenin equivalent voltage is nothing but what is the open circuit voltage seen across those points. You don't have to replace it with anything. The same circuit you have to retain. And you just see what is the open circuit voltage appearing across it. So this is your V Thevenin. So V Thevenin is nothing but VAB. So when the reference node is not given, you have the liberty to choose a reference node for yourself. So let us choose this as a reference node. A reference node means the node which has zero potential. So the potential at this point is 0 volts. Now, you know that this is open circuited. So the current through an open circuit is 0. So you don't have a current in this path as well as in this path. That means whatever is the potential at A, which is VA, the same will be the potential here because there is no drop across 20 ohms. Similarly, the potential at B is the potential at here, same. And also you know that this current 3 angle 90 will flow only through this J40. It cannot go here because it's an open circuit. Similarly, the current 2 angle 90 will flow only through J20. It cannot go here because it's an open circuit. That means your VA is the drop across 40 ohm inductor, which is nothing but J40 times the current, which is 3 angle 90. Make sure the polarity is satisfying the polarity you chose, because for an inductor, with an inductance with a reactance X, the current is flowing from top to bottom or any one direction, the voltage will be higher in that point. That means if this is your IL, this VL is nothing but your IL times JXL. Current always flows from higher potential to lower potential. Now, whether that current is positive or negative, you don't know because you are just naming it by variable name. So, you gave a variable name for the current and you chose a direction for that current. So, you can choose the variable name for voltage, but that voltage polarity will now be fixed. So, that VL is given by IL times JXL. So, in this case, also it is true. The point which I am trying to make is if your voltage current was like this 3 angle 90, that means this 3 angle 90 will go like this. In this case, in the blue case, your VA is not VJ40. If VJ40 is this, that means VA is not 3 angle 90 times J40, but it is minus 3 angle 90 into J40. But in the given problem, we don't have to think about it. Even if you don't know this, you default right like this way. But always make sure that the polarity is satisfied. So the current always flows from higher potential to lower potential. So if you are going to write a voltage potential, you have to make sure that you mark the current from that potential to downward and you make it as a positive value. So here your VA is nothing but 3 angle 90 times J40. And similarly, your VB is same direction. Current is going from top to bottom and the top potential is VB. So VB is 2 angle 90 times J20. So you have your VA and VB. So you can get your VThevenin. VThevenin is nothing but VA minus VB. So which is 3 angle 90 is J3 times J40, which is minus 120. Your VA is minus 120 and your VB is 2 angle 90, which is minus 40. So now this becomes minus 120 plus 40, which is minus 80 volts. So you have your Thevenin voltage as minus 80 volts and your Thevenin impedance as 20 plus J60 ohms. So if you draw the equivalent circuit, you have minus 80 volts, +20 plus J60, and your AB. Angle 0, or it is 80 angle 180 volts. This means nothing but 80 angle 180. That's it. That is a solution. Now let us move to the next problem. Please try to solve this. the value of V1 and V2 is, sorry, the value of current I, which is current I is not given. So let us assume this is the current I. Since a reference node is not given in the problem, let us choose this as a reference node, which is 0 volts. And this voltage is anyway given in the problem, which is V1. So this is also V1. Now we know that both these 8 ohms are connected in parallel. That means the voltage across them are same. And the current through one 8 ohm is known, which is I. So the current through this 8 ohm is also I. And this is I, and this current is 2I. So if you take the node V1, at node V1, if we apply Kirchhoff's current law, and this current is say I1, we can see that I1 is nothing but I plus 2I, because all the currents are leaving and I1 is incoming. Incoming currents are equal to the outgoing currents. So this becomes 4I. Now, V1 is the potential across 8 ohm, which is given by 8 times I, because I is the current through 8 ohm. So if we apply Kirchhoff's voltage law in the loop, say let us take this loop, then I can write V2 minus 4I1 minus V1 is equal to 0. Now I1 is already known. I1 is given as 5 ampere in the question, which implies you will get your I as I1 by 4, which is nothing but 5 by 4 or 1.25. So this is V2 minus 4 times I1. I1 is 5 minus V1 is equal to 0, or V2 minus V1 is 4 5s are 20. So this is one equation. But we already know V1 as 8 times I, which is 8 times I is 1.25. Which comes out to be 10 volts. So you obtained your V1 as 10 volts. Now if you put this in equation 1, you will get your V2 as 20 plus 10, which is 30 volts. So you got your V1 and V2. So this problem is application of Kirchhoff's voltage law and Kirchhoff's current law. Let us move to the next question. The voltage across and current through a load are V of t is 2 cos 3t plus 5 cos 5t plus 8 cos 60, and I of t is 3 cos 3t minus 30 degree plus 5 cos 4t minus 40 degree plus 6 cos 60 minus 60 degree respectively. Find the power absorbed by the load. Now you are asked to find there is a load and the voltage across the load is given by the question, and the current through the load is also given. You are asked to find how much power is absorbed by the load. So by power absorbed we means the real power or the active power. Both are same. Now this power is nothing but average of the instantaneous power. So this power is also called the average power. Now we know that the instantaneous power is the product of instantaneous voltage and instantaneous current. So in the given problem you are given the instantaneous voltage which is 2 cos 3t plus 5 cos 5t plus 8 cos 6t, which is a voltage, and the current is 3 cos 3t minus 30 degree plus 5 cos 4t minus 40 degree plus 6 cos 6t minus 60 degree. So this is your current. So the product of both is the instantaneous power. Now the average of this instantaneous power is your real power. Now if you say or a general case where your voltage is, so general case where your voltage is V1 cos omega 1t plus V2 cos omega 2t plus V3 cos omega 3t plus so on, and your current is I1 cos omega 1t minus phi 1 plus I2 cos omega 2t minus phi 2 plus I3 cos omega 3t minus phi 3, so on. So if you want to find the average power in a circuit whose voltage and current are given in this manner, you just first multiply them to find the instantaneous power. So when you multiply them, let us go step by step. So I multiply V1 cos omega 1t with your I1. So I1 is I1 cos omega 1t minus phi 1 plus I2 cos omega 2t minus phi 2 plus I3 cos omega 3t minus phi 3 plus so on, plus V2 cos omega 2t into this whole plus V3 cos omega 3t into same current. So this will go on plus V4 into same thing. So this is your instantaneous power. Now I am taking it outside the bracket. So this will become V1 cos omega 1t, I1 cos omega 1t minus phi 1 plus V1 I2 cos omega 1t cos omega 2t minus phi 2 plus V1 I3 cos omega 1t cos omega 3t minus phi 3 plus so on plus v2 I1 cos omega 2t cos omega 1t minus phi 1 plus so on it will go. Now these terms which I am marking it with orange belong to same frequency component. So here it will be v2 I2 cos omega 2t cos omega 2t minus phi 2 so on. So these are similar frequency terms and the others are dissimilar frequency terms. Now the similar frequency terms, this will become v1 I1 cos A cos B. What is cos A cos B? Can someone tell me? Okay. So cos A cos B is cos A cos B is half cos A plus B plus cos A minus B. So this becomes by 2 cos A plus B. A plus B is 2 omega 1t minus phi 1 plus cos A minus B. A minus B is omega 1t minus omega 1t minus of minus is plus phi 1. The next terms become v1 I2 by 2 cos A plus B is omega 1t plus omega 2t minus phi 2 plus cos A minus B, which is omega 1t minus omega 2t plus phi 2, so on. Now for the other similar frequency term, this will become v2 I2 by 2 cos 2 omega 2t minus phi 2 plus cos omega 2t minus omega 2t minus of minus phi 2, which is cos phi 2 plus so on. So now this is your instantaneous power. For the average power, which is the average of your instantaneous power, you will integrate your P of t over its time period. Now, integrating a sine or cosine wave over its time period will give you 0 because you have your sine as this and your cos as this. So in a time period means in a full electrical cycle, so the positive and negative halves are equal. So you have your average value as 0. That means in this expression, wherever cos terms or sine terms are coming, so in here we have only taken cos, so this will be 0, the average value. And similarly this will be 0, this will be 0, this will be 0. That means if you observe, the similar frequency terms will have their phase difference term. So only that phase difference terms exist in the average power. That means your average power will have v1 I1 by 2 cos phi 1 plus v2 I2 by 2 cos phi 2 plus v3 I3 by 2 cos phi 3 plus so on. That means when you have voltage and current with different frequency components, you can observe that the similar frequency components will only constitute the real power. The dissimilar frequency components will not constitute real power. That means the real power is constituted by only similar frequency components or similar frequency voltage and current. So in the given problem, you have in the voltage you have 3 omega is 3, omega is 5 and omega is 6. And the current you have omega is 3, you have omega is 4 and you have omega as 6. So you see that only 3 and 3 and 6 and 6 will contribute to the real power, because since 4 is there in current but not in voltage, similarly 5 fifth harmonic component or 5 omega t is there in V but not in I, so both of them will not contribute anything to the real power. Now the value of this is given by the peak value of both divided by 2 times cosine of the angle between them. So this is the real power equation. So in this case, it is peak of 3 omega, peak of 3 omega of I divided by 2 cosine of angle between V3, 3 omega t. So 3 omega t is 3 t in voltage and in current it is minus 30. That means the angle between them is 30. If you draw it in phasor domain, for omega equal to 3, your voltage is reference, whereas your current lags your voltage by 30 degree. It is minus 30, so in clockwise direction you have to draw. So your phi 1 is 30 degree. Now let us take for omega equal to 6, because 4 and 5 does not exist. So in 6, omega equal to 6, your voltage is again lying in the reference, whereas your current is 60 degree lagging. It is minus 60, that means in clockwise direction you have to draw 60 degrees. So this is your I. So this becomes plus V6 I6 by 2 cosine of angle between them is 60 degree. Now what is the value of V3? V3 is the peak of omega equal to 3, which is 2, times I3 is the peak of omega equal to 3, which is 3 by 2 cos 30 plus V6. V6 is 8 times I6. I6 is 6 divided by 2 cos 60. So this is your average power or real power or active power contributed by the circuit. So you have the value for 4 times 6 cos 60. So this comes out to be 14.59 watts. So the basics of power, active power is formed only by similar frequency components, and this is how you find it. The peak of both multiplied by peak of both divided by 2. That means if your voltage is Vm angle 0 and your current is Im angle minus phi, where Vm and Im are the peak values, not RMS, peak values, then your power is Vm Im by 2 cos phi. And this is formed by, provided they are of the same frequency. So that's all for today's class. Thank you.